Okay, let's have a look and see how this practice example pans out. Well, firstly, let's see if we want to determine AG to GF, this one, AG to GF. Well, what do we know? I want you to look at triangles. This is number A. I want you to focus on triangle ACF. Triangle ACF there. Look at that one there. Let's color code it there. Triangle ACF. There we go. Now, if you look at this, what do you notice? We've got the lines are parallel. So if the BG is parallel to CF, then immediately we've got the ratio A to G is also 2 parts to 3 parts. Remember, that's 2 centimeters. It's 2 to 3. So then AG to GF is also 2 to 3. So we can say, here we go, we can say that AG to GF is equal to 2 to 3 as well. And that's because BG is parallel to CF. That's given. So we sorted with that one. Okay, now what about this one? Determine EG to GA. Okay, where's that? EG to GA. Now this is quite easy. Watch this. If you think about it carefully, AF is equal to FE. Do you agree? AF is equal to FE. So that means that if you've got AG being 2 and GF being 3, then FE must be 5. Okay, so in other words, if you look at this, if we want the ratio of EG to GA, EG to GA, well, what is EG? E to G is actually 8, and GA is 2. You see that? Look at that. EG is basically 5 plus the 3, which is 8. So there we've got it. So let's write a proof for that. Number B here. Let's see what we get. We can say, look, EG, okay, EG to GA is going to equal 8 over 2, which is basically 4 there. Can you see there? So what you did is you see that that's 2 and 3, but AF is equal to FE. So that means FE is 5. So GE must be 8, and AG must be 2, giving you 4. Okay, what about the third one? Prove that DG is parallel to CA. Prove that DG is parallel to CA. Okay, alright, well, where's DG? Let's have a look here. Here's DG, is this line. DG has got to be parallel to CA. Now we've got to prove that. Well, let's see, how would we go about doing that? Well, if we take and focus on triangle, the big one, ACE, what do you notice? So let's write that down, number C. In triangle ACE, well, what do we know? Okay, let's see, what do we know in triangle ACE? Well, we've got, if you look at that, if you take the ratios now, you've got, I want you to look at EG to GA. We've already worked that out. EG to GA. Okay, what is that? So EG to GA was 8 over 2, which is 4. But now let's go to the other side. Okay, so we've got EG to GA. Look at that again, EG to GA. And what is that? ED to DC. Now what's ED to DC? ED to DC is 4 over 1, which is 4. Look at that. See that there, 4 centimeters over 1 centimeter is 4. So in other words, what we've now got, and this is the nice part of this, you've got in this triangle, this big one, you've got, look at this carefully, you've got EG to A divided by AG is ED divided by DC. So those ratios are the same. So what can we then conclude? We can say, therefore, EG over GA is ED over DC, and therefore, if that holds true, if EG over GA is ED over DC, or we can therefore say that, therefore, we can immediately conclude that DG is parallel to CA. Okay, because the line divides the sides proportionally.